Hi, my name is Kerim Satirli. I'm a senior developer advocate at HashiCorp. We're focused on infrastructure and orchestration tooling. Thank you for joining our session on how to discover, govern, and scale Microsoft Azure resources with HashiCorp Terraform. Now, today's session is about a problem every Azure team has, but very few have a clean answer for. The gap between what's in your Terraform state and what's actually running in your subscriptions and tenants. So sit back, let's get ready to dive in. Every practitioner and customer team I talk to gives me a coverage number, 80%, 90%, sometimes higher. And when we actually sit down and compare the Terraform state against what's running in their subscriptions, the real number is somewhere between 40 and 60%. Some do really well and actually hit 80%, but no matter the number, they all think one thing. We do everything with Terraform. The gap here isn't dishonesty, it's that nobody's measuring. Resources accumulate outside infrastructure as code for entirely human reasons, which we'll get to in a moment. And then the path back from unmanaged to managed has historically required a heroic engineering effort, or a freeze you couldn't actually afford. That's the problem this session is about. By the end of the next 20 minutes, you'll have seen a workflow that closes that gap in a quarter rather than a quarter year. Quick sidebar, if you've heard of infrastructure as code but aren't entirely sure what it or Terraform is, think of it this way. The traditional way to provision resources and deploy resources in Azure is to open the Azure portal, find the service you want, and then manually click together your infrastructure. While this seems fast, it is error prone. Because to get the same exact result, you have to click the same exact buttons next time and not make any mistakes. Comparatively, infrastructure as code allows you to describe your infrastructure in human readable text files that you can version control and review with your colleagues easily. And because it is code, tools like Terraform can parse it and turn your prose into provisioned infrastructure. So with all those benefits, you might wonder, how do resources end up not being codified? Well, there are 4 patterns I see most often. And none of them are actually failures of engineering discipline. The first is the most common. I'll codify it later. Somebody with all the right intentions clicks something in the portal during exploration, fully meaning to bring it under management later. But later never arrives. The second is a 2 a.m. incident fix. Because writing Terraform and any infrastructure as code while production is down is sometimes a hard sell, especially for teams that do not codify everything. The third is a classic, the acquisition. You inherit an environment you've never seen and you don't even know what's in it. All you know is that there's a new subscription in your account with stuff that doesn't look like it belongs. And the fourth is the POC that became production. Because it worked and nobody had time to rebuild it properly. Because it was already live and serving customers. Point of this list isn't to prevent these situations. You can't. You absolutely can't. They are going to keep happening. The point is to have a fast path back. And this is even worse when you're running AI workloads. Not agentic loops to generate code. No, actual GPU resources for your AI, LLM, and machine learning infrastructure. When you can't attribute cost because you're missing important tags, your organization will have a harder time figuring out which experiment, which team, and which project a given resource belongs to. And of course, network isolation is a huge problem. Your training environment and your inference environment have very, very different security postures. And one ungoverned subnet can collapse that boundary. Identity sprawl is a third, and this one's specific to agent-based architectures. Every agent has managed identity. Every managed identity has scopes. And if those scopes aren't defined in code, your audit story falls apart the moment somebody asks. And we're not even diving into the blast radius of leaking data because your storage account is allowed to be publicly accessible. Now, if we briefly switch to our terminal, Terraform, of course, understands this problem. Traditionally, you'd use the CLI to import some Terraform with the import command. Terraform has support for this and has supported it for years and still does. It works, but it is very much one resource, one address at a time, and therefore it is time consuming. Since Terraform 1.5, you can do this with import blocks. Discovery is still on you, but this is a real improvement over the old workflow. You get a plan first model, you can review the generated config in a pull request, and you can apply when you're happy. If you've adopted this pattern, you're already in way better shape than most teams. But notice what's still missing. You're still writing that import block yourself, even if you have some tooling that may infer it. This means that you already need to know what the resource ID is inside Azure. You need to know that the resource actually exists. Now, enter Terraform Search. This feature is available in the Terraform CLI since Terraform 1.14, which was released in November 2025, and it upgrades the way you're going to do imports in the future in an absolutely amazing way. The whole process is so simple, it consists of 3 steps. First, we define a search query. Say, give me all unmanaged MS SQL servers in my subscription that are in the MS Build resource group. Then you run the Terraform query command on the CLI and let Terraform do its job. It authenticates to Azure the way you normally do and starts querying the remote API for all the unmanaged servers. Give this a minute or two, depending on how much data you have and how many resources your query is looking at. And then you're ready for step 3, generating code. Yep, no more hand coding everything, hoping you don't make copy-paste errors or forget an attribute. With Terraform Search, you get the code generated for you, stored in a .tf file so you can inspect it, peer review it, and make sure you're aligning your resources to your organization's requirements. Search inverts the import question. Instead of a situation where it's very much around, I know what I want, now help me write the config, this changes it to show me what's there, generate the config from it, and then let me plan the import. 3 commands instead of 3 weeks of inventory work. Let that sink in for a second. And now let me show you. Let's first have a look at what we're dealing with. I'll open the Azure portal in my browser, and I can see our subscription. I'm in a single resource group, and you can see roughly 30 resources scattered across it. Networking foundations, security groups, a NAT gateway, a storage account, and a function app. And of course, private DNS to put it all together, public IP addresses, and much more. Sadly, all of this is unmanaged. And you're not even seeing the worst of it. Some of these have tags, others don't. Sometimes the tags match a format, sometimes they don't. And now, I know this is not a heavy ask, but pretend for the sake of this demo that 3 different teams click this environment together over the course of a year. I know I've been there. I know you've been there. So you know what we're looking at. Different conventions, no central inventory. Nobody's entirely sure what depends on what and which resources we can upgrade without breaking the others. So let's change that. Let's remove some of the risk and make this usable. First, we'll write out the query for the resources we want to discover. There are too many resources to fit in a single screen, so I'll highlight 3 of them. I'll start with a NAT gateway because I absolutely want that to be managed. Then the security groups, because if there's anything I want to manage through Terraform right away, it is definitely my security stuff. And of course, the 2 public IP addresses. By managing them through Terraform, I can bring them into other systems. I can use the whole Terraform provider ecosystem and make sure those IPs end up in my monitoring tooling. They end up in my on-premise systems that need access, and much more. Now, if you're looking at your screen, you'll notice that I'm not specifying any Azure credentials in this file. Reason for that is simple. Terraform search inherits these from your overall provider config. So as long as your normal Terraform plan run can succeed, Terraform query, the CLI command, can also and will also succeed. If I want to be even more prescriptive, I can configure each query to look only at a specific resource group, for example. In this case, I'm saying for the NAT gateway, only list unmanaged resources in the Microsoft Build 2026 unmanaged resource group, which are created specifically for this session. Then back to Terraform and execute the Terraform query command. And after a few seconds and a few CPU cycles, we'll see our resources appear. Now, for the sake of this demo, I'm showing you the first two. But anything I query for would show up here as long as there's a match for my query. Keep in mind that if you set up constraints here that result in the API not returning anything, Terraform also won't be able to find it. So don't hardcode the variable, don't hardcode the resource names, use variables, and make sure everything makes sense. But in this case, everything looks good, so let's export our config. For this, I'll use the Terraform query command again, but this time I specify the path I want to save the config to. And again, after a few CPU cycles, I can switch to my editor and inspect the newly generated unmanaged.TF file. And I'm showing you an excerpt here because ultimately those 4 resources generate about 200-300 lines of import statements and resource definitions. But right from the top, you can see that Terraform left a comment to let you know this is a generated file. Not shown on screen, but definitely in your file is a word of warning from Terraform to inspect and verify everything. We'll do that in background and meanwhile continue onwards. The 4 resources that I discovered are good for almost 300 lines. So I invite you to try this out yourself instead of watching me scroll through a long file. But I do want to show you one part. Below each discovered and config generated resource, you also have an import block to easily import this newly discovered and currently unmanaged resource into your Terraform state. All it takes is one Terraform plan and apply cycle. And of course, because this is using the import block, you can easily use HCP Terraform for this. Now at this point, you might be wondering, are we done now? We imported everything, right? No more unmanaged resources. We learned how to do this in an almost programmatic way. You can bring in the HashiCorp Terraform agent skills and get a lot of this set up programmatically and through agentic loops. And yes, we could totally stop here. We could take a few minutes back, but there's one more thing I want to show you. We already made huge leaps. Now, I want to go from managed to the next level. We discovered, we imported, but in doing so, we retained all the old configuration. Terraform did not make any changes to it unless you did. So the managed section is done. So let's mark this section as done. Now, what's next is to apply our organizational policies to our newly imported resources. This will allow us to eliminate drift and make sure any resources we imported feel and behave like other resources, with the right tags, the right naming conventions, and many, many more things we can query for, such as appropriate instance types, making sure we're using the right SKUs. Whatever you can imagine and want to create a policy for, this is a path you should be on. So let's switch back to our editor and create a Sentinel policy. HashiCorp Sentinel is a policy framework that blocks Terraform from carrying out operations that are not in line with your policy definitions. We'll start by defining the types of resources we want to match against. Here, we got our set of public IPs, the NAT gateway, and the security group. Next, will collect all planned resources that are taggable whenever we run a plan. And then we'll process these resources in a loop and collect their tags. You'll notice a comment sign there, because in the interest of not flooding your screen, I'm only showing you a few lines of code at a time. So let's look at the policy separately. Here we've got a simple conditional where we check for violations like a missing owner tag or an owner tag in the wrong format. Now this is purely for demo purposes. Of course, in your case, you'll have many more policies. And if you're wondering, how do I even get started with that? Check out the Terraform registry at registry.terraform.io, where we have a handful of amazing policy packs specifically for your Azure use case. But in this case, our policy is written. So just like with Terraform, we'll apply the policy through Sentinel. And again, after a few CPU cycles, we can see that the results return and our resources are in fact not aligned with the organization's naming policy. This is exactly what we expected. We imported resources that we knew were not following organizational guidelines. Terraform happily imports those. Sentinel then prevents you from making further changes until you've eliminated this drift. That being said, we're using Sentinel in a soft fail mode here, so we could still continue and just get an advisory, but for what it's worth, start working on a hard fail as soon as possible to make sure your infrastructure is governed the right way. Though fixing all of this is a task for another time. For now, we're at the stage where we can rely on our infrastructure to be Terraform managed and governed by appropriate policies using Sentinel. And that brings us to the conclusion of this session. Hopefully you've learned something new, and I've been able to inspire you to bring more resources under Terraform management and go the extra mile to govern them appropriately with organizational policies that make sense for you and your organization. Remember, use the Terraform query command to bring unmanaged resources under management. And use Sentinel to enforce policies that make sense for your organization. Finally, here are 3 links I think are worth looking at. We've got the documentation for the CLI commands, a blog post diving into the why and how of Terraform query, and of course, a Sentinel playground to see the full policy in action. With that, thank you so much for joining. Have a great day and a great rest of Microsoft Build 2026.